Hello, my name is Juan Muñoz, and I will be the speaker today of this webinar. This is a project we developed last year called a benchmark report comparing 6 Latin American public transport systems. I hope you can hear me, and I'm going to start moving ahead with the presentation. So let me start by saying which were the goals of the study. This was a work that was done with Marco Batarse and Ignacia Torres from the Center of Excellence at Universidad Católica. And this was something we did with Santiago, the transit agency in Santiago de Chile, because they wanted to understand how the level of service perceived and received, not perceived, received by people in Santiago compared to other cities in Latin America. So the goals were to compare some indicators of the transit systems, and by transit system we mean not just buses, but the whole formal transit systems composed by buses and also by metro. The idea was to consider the full urbanized metropolitan area, not just downtown, and that made some of the cities, for example, Ciudad de Mexico, extremely large. The idea was to focus during the morning rush hour, so it's not a full day analysis, but only the morning rush. And we wanted to compare the real level of service offered to users for different trip characteristics, because that's something difficult to do unless you start segmenting the trips. So we wanted to segment trips from different distances, let's say short trips, medium-sized trips, and long trips, different transportation modes, for difference in infrastructure, etc. The assumptions that we made were that users would always take the fastest route, so even if it was a little bit more expensive, that's what people would do. And we measure the real level of service, not user perception. So this is not done by asking people about their experience, but going to the field and measuring what people were actually experiencing. And we left aside all the informal or paratransit services, which was only formal and massive transport were analyzed. So basically BRTs, buses, and metro. And we collected very different indicators, 100 of them in each of the cities, ranging from socio-demographic, operational, fares, contracts, infrastructure, vehicle characteristics, information for users, and user perception. And however, what we thought it was more interesting to compare in this case, and that's where we made some deep analysis, was in operations, because all the other were some elements that where we compared of data was already available, but we realized that identifying operational performance indicators was tricky, because it depended very significantly on how you measure it. For instance, let me comment what happens, for instance, with waiting times. If you ask an agency about what are the waiting times in their city, quite likely they will just average all the frequencies of all the services that are offered, and take the average, and with that average frequency get an average interval between buses and divide that interval by 2. And this doesn't take care of several issues that make waiting times very different. For instance, some of those services, bus services, may have very different demand. Second, maybe those services don't have regularity, meaning that if the buses maybe arrive, instead of arriving regularly, arrive in platoons of 2 buses each, then the average waiting time will be twice as high. So that's something we needed to know. We wanted to really understand the differences between cities, but doing a very rigorous, or as rigorous as possible, comparisons by looking at field data. So that's what we did. We wanted to obtain these performance indicators from observations because they are very hard to find in the literature, and a common methodology is needed to make a fair comparison. And this is what we look for. We will look for travel times, walking times, waiting times, in-vehicle times, operational speeds, frequency, reliability, and number of transfers. And it's interesting also that these are indicators that vary very significantly among different trips. So for small trips, for long trips, this could be very different. So we needed to come with a methodology that allowed us to have an indicator of the full city that could be comparable among cities, and this is what we did. We looked for cities where we had a public transport OD matrix, and this left aside several cities just because they didn't have an OD matrix, or because the OD matrix was not available for us. That's one of the reasons why we didn't consider Rio de Janeiro or Sao Paulo. In those cities, the public transport OD matrix apparently is property of a private agency, private consulting agency, and they were not able to give us access to the information. Second one, once we have, sorry, let me go back. Once you have this OD matrix, what we do is to raise a sample of 400 trips of those of the OD matrix. Why 400 trips? Well, we looked at the OD matrix of Santiago de Chile, and we realized that forget a sample that could give us an average that was within a certain statistical significance, we needed around 350 trips for a random sample, for a 95% of significance, etc. So what we did was to increase this sample from 350 to 400, but not only that, we didn't consider a random sample. As I'll show you, we looked for a sample that could represent very well the kind of trips. So for instance, if you have short, let's say half short trips and half long trips, our sample will have exactly 200 short trips and 200 long trips. So we looked for a sample that could represent very well the major trips in the city, from between macro zones, the percentage of trips that are going inbound, outbound, etc. So the sample was done in the following way. Imagine that you take the trip, the full OD matrix. We usually have hundreds of zones. We added those zones, we aggregated them into macro zones, let's say 10 macro zones. And we have now an OD matrix that is really 10 times 10. It's a 10 times 10 matrix, not a 100 times 100. And therefore, in this 10 times 10, we looked for the percentage of trips that were in each cell. And we forced our sample to have exactly the same percentage of trips from this aggregated OD matrix. So for instance, if from macro zone west to macro zone northeast, there's 10% of the trips, then we would have exactly 40 trips from our sample, from the sample we analyzed. Once you have the 400 trips, we identified for these 400 trips a particular address in the city as an origin and a particular address for the destination. We determined the fastest itinerary for each of them. And we did this by looking at experts in the city that could tell us this is the reasonable way to travel between these two addresses. Then we obtained the distance of each of the triplets for each of the 400 trips. We measure operational speeds, frequencies, and reliability of a subset of services in each city. This means that instead of going to the city and making the actual trip, what we did was to identify the speeds and the frequencies and the waiting times. What we did was to take a sample of the services in the city this sample should be able to represent all the the kind of trips that our sample of 400 trips were doing, and we measure some performance indicators of those particular services. And then, based on the sample we raised of speeds, frequencies, etc., we were able to estimate in-vehicle walking and waiting time for each of the 400 trips. So for instance, imagine that one of the trips would go from downtown to the periphery in a BRT service. Then what we did was to, in our sample of services, there was at least one BRT service that would go from downtown to periphery, and we measured several services that were doing that trip, and then we assigned from all the trips we measured from a BRT corridor going from downtown to the periphery, the same level of service to the particular trip that we were going to analyze, meaning that it would have exactly we assume that it would have the same speed. Based on this information for the 400 trips, we derived across trips variability and within trip variability, and this is very interesting. We were interested here not only in understanding, for instance, we were interested in understanding two types of variability. First is for trips that are the same length, for instance, 5 to 10 kilometers. For all the trips that are 5 to 10 kilometers, how do they vary across the city? And we think this is interesting because it tells you how equitable your city is in that sense. So maybe there are some areas in the city that have very good transportation system and make those 5 to 10 kilometers very fast, and maybe there are others that are very slow. That would be an indicator, we think, of not very good equity, because the across trips variability would be very high. And by within trip variability, we mean that trips, what also we would like is the same person doing the same trip every day would have a kind of reliable service. So we would expect that the variability within different instances of the same trip, we would like the variability to be low. So when it's low, we mean when we find that there's a low variability, we mean that we assume that this is an indicator of a reliable system. So these are the two types of variability that will be present in my discussion today. So let me start by presenting some general information about the cities, which I think is interesting because it allows us to understand what are these the 6 cities that we analyzed. We have here Santiago, Mexico, Guadalajara, Porto Alegre, Bogota, and Lima, and we can see that in terms of population, we have here on the left-hand side only the population of the the downtown area, but the metropolitan area we consider is considerably higher than what we had in this column. On the second, because it is only the population of downtown. Really, the population of the city is significantly higher. For instance, Santiago has around 6 million inhabitants. When in the second column, it's very important, we have the surface, and the surface is how big is the downtown area, and we have here on the third column the density, the income, the number of trips, and the public transport share. It's important to say that the area that we consider is not exactly what we have here. Here we have only the downtown area. The surface we consider for each of the city is significantly higher. Sorry, I have a problem here with the computer. Okay, I hope I'm back and that everything is going well. Here I have the bus firms and the BRT firms and the bus fleet and the number of segregated corridors in each of the 6 cities. We have we noticed that in the case of Mexico City and Lima, there are many more bus firms than in the rest of the other 4 cities. We have BRT firms running only in Bogota, Guadalajara, Mexico City, and Lima. And the bus fleet, it's very important to check that the bus fleet in Mexico City, for instance, is huge, but it's a very big city. And in Lima and Bogota, it's also very big, especially if we compare Bogota with Santiago, which are similar size. Santiago appears to have a much lower fleet. Guadalajara and Porto Alegre, which are smaller cities than Santiago and Bogota, also appear to have, in the case of Guadalajara, a similar fleet than Santiago, and in Porto Alegre it's significantly smaller. And we have at the bottom the number of kilometers of segregated corridors. In terms of metro, we only have metro in this case in Santiago, Guadalajara, and Mexico City. We didn't consider the metro in Lima because it wasn't relevant for the 400 trips for the sample of 400 trips. And here we have the fare paid for in each of these cities, but in the case of Santiago, the fare allows you to integrate with the whole system, so it's a little bit, it's not as comparable. Here we have the extension. In the case of Santiago, we have 100 kilometers, twice as much we have in Mexico City, and in Guadalajara, the light train has only a quarter of the Santiago network. Here we have an idea of the average headway in the system, and if we have presence of express services, which, as we understand, are only in Santiago de Chile. Let's move to the main results. The Santiago and Bogota, in terms of average speed, Santiago and Bogota offer comparatively high average speeds in terms of door-to-door and in-vehicle. By door-to-door, we mean origin to destination, in which we include walking time, waiting time, transferring time, and all the legs, of all the trip legs. However, in in-vehicle, we are only focused on the speed experienced by users while they're inside the vehicle. And they're also fast in comparatively with the other cities when we for any given distance category, even though for very long trips Mexico does pretty well because it has very long trips doing mostly suburban trips with very high speed. But for let's say short trips like 5 to 10 kilometers, we'll see that Santiago and Bogota performs better than the rest. And it's important here to understand that usually longer trips take longer but enjoy faster average speeds. And that's what we see in Mexico City. Here we have a graph showing for each of the 6 cities, we have in blue the columns of the distance. Right? And we can see that Mexico has much longer trips than the rest of the cities in average. And in red, we have the average travel speed for the whole trip, door to door. And you can see that on the right-hand side, the speeds. So in this case, Santiago has a speed of around 14 kilometers per hour, while Bogota has around 13. And Mexico does reasonably well, but for a very long trip. Let's move to the same graph, but only looking at the in-vehicle distance. And we can see that inside the vehicle, Santiago provides a much higher speed than anybody else, and this is mostly because of the large fraction of people in Santiago using metro, which provides a very high speed. In second terms, we see Bogota. As a third graph regarding speed, I would like to focus only in trips between 5 and 10 kilometers. So we do this analysis to try to put aside the difference between the different cities. That some cities are larger or shorter or smaller, sorry. In this case, we say let's look at only at trips between 5 and 10 kilometers. And on blue, we have the distance, and you can see that they are all between 6.8 kilometers or 6.9 and 7.4 kilometers in average. The number of trips we measured in this category, in each of these categories, and the average travel speed again of these trips of Santiago and Bogota comes first, and Mexico doesn't do very well because of the high congestion in Mexico City, which have a speed that is significantly lower. This is the average speed for door-to-door for trips that are 5 to 10 kilometers. Again, I have a problem here with the, I don't know why, with the presentation. Give me 1 second. Okay, I'm back. I hope I'm back. Let's move to this table that gives us some in-vehicle speed by mode. Some issues should call our attention. For instance, as we said before, the speed in Santiago is particularly high for in-vehicle speed, and it's basically because of the metro. Metro has a very high speed of 33.4 kilometers in comparison to much higher than anybody else, even though the BRT of Bogotá does very, very well too, with 27.2 kilometers per hour. The metro of Guadalajara also is pretty good, and 26 kilometers per hour. And in the worst case side, we have the buses of Mexico City performing only 8.8 kilometers per hour during rush hour in the morning. So this is the difference of the in-vehicle speed we measured in each city. Some of the main results again, in terms of variability, we see that in Santiago, the travel time variability among different trips of similar length is the lowest, and the highest we found is in Mexico City. And we see this as an indicative of equity. So our conclusion is that because Santiago has a fully integrated system in which each of the users can access the system and reach their destination to the fastest possible route for the same fare, we think that this is a very good service for the people in Santiago, and this is the reason why the variability of the travel time is the lowest. And regarding reliability, in most systems the variability of waiting times for bus services was very high, and that's a problem worldwide about how to address or how to provide reliability to bus services that are headway based instead of timetable based, as is sometimes in the northern hemisphere where they have lower frequencies. But in the developing world where we have high frequencies, where there's no timetable, reliability is a very big issue. And Metro has a very high reliability. It's almost zero in those places where we measure it. And in our sample, the lowest variability was observed in Lima, Porto Alegre, and Santiago. In the case of Lima, it's also because they have a very large fleet, and therefore the waiting times are very long. So here we have the average travel time for each of the cities, and you can see that in terms of travel time, Lima does reasonably well, Santiago too, but this also depends a lot on the size of the length of the trips that are part of the sample. And you can see that the variability, as I said, citywide variability of Santiago is the lowest among the 6, and the highest is found in Mexico. And in terms of reliability, which is individual variability, how the same trip changes day to day, we can see that Lima does very well because, as I said before, they have a very large fleet, but also you have low individual variability in Porto Alegre and Santiago. If we do look at the same graph, but focusing in trips that are within 5 to 10 kilometers, this is what we see. These are trips that are the same length. Again, it should call our attention how long the trips are in Mexico City, and not only how long, but also how unreliable and how much it varies across different trips that are located in different parts of the full city. Let's move now to the in-vehicle time. And the in-vehicle time, it's very long in the case of Mexico, and it has very high variability and very high individual variability. In the rest of the system, the cities are pretty much quite similar to what we've already mentioned. And this is how the in-vehicle time for trips between 5 and 10 kilometers vary. Again, Mexico City appears to be performing not very well, and Santiago, for this category, does reasonably well in terms of in-vehicle time. It's low in terms of the amount of minutes, the number of minutes that people in an average spend inside the vehicle. Again, so I have again a problem with. Okay, I'm back. So that Santiago does reasonably well with low variability and low in-vehicle time, and this is basically due to the number of people using metro, which metro appears to be very reliable. Regarding waiting times, in Santiago, Guadalajara, and Porto Alegre, the waiting time is higher than in other cities, and it should be something that worry people in Santiago, because Guadalajara and Porto Alegre are smaller cities. Bogotá, Lima, and Ciudad de Mexico, they have a large fraction of services that are unregulated, and that's why people tend to also to wait less, because in Santiago buses have to stop only no, this is not because of stop. This is because in Santiago we have a lower fleet. And the fleets that are in Ciudad de Mexico, in Lima, and in Bogotá are significantly larger than in Santiago, which has only 6,000 buses, which appear to be pretty low for a city of its size. And this is one of the reasons why the waiting times are so high. These are the travel time composition. You can see how in Mexico City you have very large in-vehicle time, and as we said before, the in-vehicle time in Santiago is quite low. However, the waiting time and the walking time in Santiago are higher than what they should for a city that are the similar size. Please compare to, for instance, to the bar of Bogotá, where they have by the end a similar total travel time. However, the waiting because the waiting time and walking time are significantly lower. So this is something that Santiago should work on. In the case of Mexico City, the waiting time is not very high, although the walking is quite high too. We'll go in detail in this in walking times in a minute. This is what we obtain in terms of waiting. Again, looking at the variability, the lowest waiting times are observed in Lima and Mexico. Those are the blue bars. And in terms of variability of the waiting time, Porto Alegre and Lima, in terms of citywide variability, does reasonably well. So it means that everyone waits a similar amount of time for the same trip, while individual variability is lowest in Lima, meaning that every day there's not much difference between the same trip during in different days. And if we focus the travel time in terms of 5 to 10 kilometers, this is how it's decomposed. Again, this is our trips that are the same length, and you can see the difference where Mexico and Lima you wait less and you walk less in Bogotá, and where you walk more is Mexico City and Santiago. These are the waiting times for trips between 5 and 10 kilometers. I'm gonna move forward because it's a little bit the same thing. So let's show you the waiting time. This is an important issue. It's how do you measure waiting time? At the beginning, we looked at waiting times by going to the field and getting the sequence of buses of a certain service that would pass through a certain stop. And if you have the sequence, you can infer what would be the expected waiting time. What would be the expected waiting time for a user arriving at a random moment to the bus stop. However, it could happen that when the bus arrives to the stop, it could happen that the bus, for instance, doesn't stop, and you're not allowed to, and therefore you cannot really board the bus. Or second, the bus arrives full, and there's no way that you will be able to board the bus. So we had to correct the waiting times based on these observations, for instance, in the case of Santiago, in the case of trans services, the average waiting time was increased by 55%, and in the case of feeder service by 29%, just because people were not able to board the first bus arriving to the stop. We did the same analysis for other cities, and for instance, in the case of Bogotá, we found very similar results. Bogotá, as everybody knows, also faces significant problems in the case of Transmilenio in terms of being able to board the first bus that arrives to the stop. So we had to build a table like this one, where you have the percentage of users that can really board the first bus, the second bus, the third bus, or so on, arriving to a stop. This is the bus fleet, just for you to remember. As I said before, in the case of Bogota, we have BRT firms and bus firms. So this problem is mostly of not being able to board the first bus. It's very focused in the BRT, but it's also observed in the rest of the system. Then we move now to walking. As I said before, the walking times in Santiago and Mexico City are also quite high. For instance, in Santiago, the average distance to access the first vehicle is 383 meters, while in Bogota it's only 209, meaning that some people in Santiago walk only to access, and then you have to digress too, but only to access the first vehicle, they walk almost twice as much in average as people in Bogota. And this is due because we don't have enough services, but also because in Santiago buses only stop at designated stops, while in the unregulated services in the rest of the cities, quite often you can stop the bus in any place. However, it's very interesting to see how low the walking times are in Bogota, and this is part of the result, where you have that in blue, the walking time in Santiago it's 14 minutes, while in Bogota it's around 8. And in yellow you have the city variability for trips that are the same length. And you can see that it's not only low, the walking time in Bogota, but also it varies very little in terms within different passengers doing different trips. And this is the same comparison for trips that are within a certain segment of 5 to 10 kilometers, where the conclusions are similar. And we were interested in comparing Santiago versus Bogota in particular because they are cities that have similar population and similar average trip length. We have the operational speed for each trip length category is also quite similar. The average door-to-door speed in Bogota, and here remember it's door-to-door, meaning that it includes walking, waiting, and in-vehicle speed, is 13.4 kilometers per hour, while in Santiago it's 14.5. So Santiago is a little bit better. But they're alike, and it's interesting when we compare that the two cities have followed a very different path. In the case of Santiago, we don't have BRT. Instead, we built 100 kilometers of metro, and we have a fully integrated system. However, we have a declining transit model share. So the percentage of passengers choosing to travel by transit is declining every year, and that's something that is worrying us. In the case of Bogota, they have 100 kilometers of BRT, and this is a very high standard BRT with high capacity buses, segregated corridors, extra vehicular payment in every station. And what I've heard, but this is something that some of my colleagues here in Chile are disputing, is that Bogota, what I've received information from Bogota, but it may be wrong, the transit model share is not declining as it is declining in Santiago, or not as strongly. So this would be very interesting to discuss, because maybe it's an hypothesis, by offering our best transit service underground, we leave the streets for the cars, and therefore we don't have a very clear. Again, I'm sorry, one second. We don't have a very clear disincentive for people in cars to shift to something else, while in Bogota, BRT is competing for the space by using by providing a very good and high standard service in the service, and people can see while you're in the car how fast the BRT is running, while you don't know really the conditions in which people are traveling in a metro in a city like Santiago, and you know how you don't see the metro going much faster than yourself while you're stuck in congestion. So this is interesting. This is a graph showing the travel time. Again, this is door-to-door, the travel time for trips that are at different length. And we can see that, yes, Santiago does a little better than Bogota, but the two graphs go very close one to another, and showing that the two models are quite reasonable. If we look at Santiago, probably we could argue that we have a great metro system, and to be able to really have a lower travel time, what we have is to have a larger fleet and more services, so people can wait and walk less. In Santiago, the speed in segregated corridors is significantly higher than in mixed traffic roads. We have very different corridors for buses in Santiago in terms of some buses running in the middle of the cars, when others we have segregated corridors, and of course those segregated corridors in Santiago offer a much better and much higher speed. For instance, in the case of Santiago, it goes from 15 to 25, just because you segregate the corridor. And this is one of my final, about to reach the end of the talk. These are operational speed, average operational speed for different infrastructures. So in the case of Santiago, this is Santiago and Bogotá again. We have mixed traffic and only bus lanes in the case of Santiago, reaching around 15 kilometers per hour. There's little to be gained, but just designating an only bus lane and not really enforcing it, because cars use it anyway. However, if you build a segregated corridor, you reach a speed of around 23 kilometers per hour, which is a significant improvement. What has been working really well in Santiago is not only designating the only bus lane as only bus, but also painting it red and enforcing its use only by buses with cameras. And when you do that, you really see an improvement, an increment in terms of the speed. But that was not measured in our analysis, because that happened after we had measured. It's interesting to see that the BRT also has a very high speed, around 30 kilometers per hour, and that's due to basically at the large fraction of buses in BRT running express. Around 80% of the fleet in BRT is devoted to express services, and of course that means that the speed is much higher. That's part of the strength of the system, to have these opportunities for buses to overpass, and by overpassing reaching higher speeds. Metro in Santiago does even better with 35 kilometers per hour, and I left the last slide, the last bar, to a type of service we have in Santiago, which is extremely interesting, and I think it's something that we should explore more, which are services that are not even express. It's like point to point, and they use the highway. It's like going from one point in the periphery of Santiago to another point in Santiago using our urban freeways, and it's a stop. One second, again I have a problem. I am back. It's a very high standard service using the freeways. It's very popular, people love it, and it reaches operational speeds of around 42 kilometers per hour, which is 20% higher than Metro. So an additional conclusion also of our study is that getting this information was very, very hard because the information availability is very heterogeneous. And we had to go and take this data of course from the field. Final observations: these are the number of triplets in each of the cities, and you can see that in the case of Santiago, people tend to do around in our sample 2.2 in average legs. In Mexico 2.6, in Bogota 1.8, and these are the number of legs done in each of the modes. It's important to say that the changes inside Metro from one line to another line, we consider them different triplets. So maybe in the case of Santiago, this blue bar, where we have, it could be that some of the extra legs are just because people are changing lines within the Metro system. So if we didn't have that, of course, the number of legs would be lower. Yeah, and in the case of Porto Alegre, for instance, very few people do more than one triplet per trip. And these are my final slide, the fares. You can see that the average fare varies significantly from 0.24 to in Lima for some trips to 1.62 for the longer trips. So it varies very significantly. So we moved it to the fare per distance, to understand how much it cost per unit of distance that people were traveling, especially because in the case of Santiago, for instance, because we have fully integrated system, it would be very unfair to assume, to compare two fares where you have a opportunity of integrating or not. And in that case, we see that the cheapest systems are Mexico and Lima, while and Guadalajara, while the most expensive is Porto Alegre and Bogota coming behind. So that's the end of my talk. I hope you enjoyed it, and I would be happy to address your questions. So please, if you could please start typing your questions in the chat area on your right. I would be happy to answer them. I hope there was somebody listening. I see 30 people attending, and everybody has been here, but I hope somebody has any. If there's no questions, well, we finish, but I hope somebody has questions. Here's a question. Well, there's plenty of questions. Sorry, let's see. Really amazing results. Thank you. What do you think would be the effect now that Bogota is implementing an integrated system like Santiago for the 70% trips in public transport outside Transmilenio? And just 2 points. One, there's evidence of a flat modal share for individual vehicle car use from the yearly survey Bogotá Como Vamos. Yeah, that's what I said. But the number of trips are growing. But yeah, that's exactly my source. My source to say that the percentage of trips in car in Bogota, it's flat. It's from that particular survey, which some people have disputed as not very rigorous. I don't know really, but it's very amazing that a city could keep the percentage of trips by car flat. In the case of Santiago, the absolute, we have reached a point where not only the modal share of transit is decreasing, but also the absolute number of trips made in transit appears to be decreasing, which is very worrying. Regarding what will happen with the integrated system in Bogota, I am really worried because, for two reasons. One reason is because in the case of Santiago, when we shifted from the disintegrated system to integration, a lot of people change the way they travel, and they tend to move from the most convenient trip in terms of fare to the most convenient trip in terms of other attributes, for instance, waiting, traveling, and of course, in the case of Santiago, the number of people using metro doubled, and it doubled because of the integration. And I think in the case of Bogota, what will happen is that a lot of people that doesn't use Transmilenio today will move toward Transmilenio. And the difference is that when we inaugurated Santiago, we had a system that had a lot of capacity. The metro was really operating at maybe 60% of its capacity, as we discovered later. However, Transmilenio doesn't have that slack. So I'm really worried about what will happen there. Second, I'm worried that the trunk corridors in Bogota are not being equipped with the same infrastructure or similar or closer to the infrastructure we see in Transmilenio, and therefore I'm worried that the actual supply will be damaged because of, for instance, longer cycle times than what you are expecting. I would like to also say something I didn't mention is that as a center we are planning to repeat this analysis looking at 7 European cities, and this is something that our friends from Lisbon will be doing. So let me move to the next question. Are there plans to introduce BRT in Santiago? I hope we do. We have very important critics from some colleagues that are impressed by the service offered by Metro and think that every mobility need should be solved almost by Metro, and they are trying to argue that BRT doesn't have a space in Santiago. I think BRT has a very strong space in Santiago. There are several corridors in which we should introduce it. One of the problems we face is that since we have a so efficient metro, people in many neighborhoods prefer to say no to BRT, expecting the government to build a metro in the future. They think that if they accept a BRT, they are in some way killing the opportunity to have a metro later on. And I've heard to the Minister of Transportation saying the most cost efficient in terms of social impact project I have is a BRT corridor in one of the main avenues in Santiago. However, I have such a strong conflict, or people complaining that resistance from the communities, that I think it's going to be very difficult to implement it. So this is a problem we have, and the cost of BRT makes it so attractive. That's something that we should move forward. I see some opportunities in the future. I hope the government will really implement. Let me move to the next question. The speed in Transmilenio is unfortunately declining. That could be the case, and I think not only the speed in Transmilenio is declining, but also the waiting times and the time it takes you to access the station because of the long queues in the rush hour is also declining. And I think there's an opportunity there. I think that's a problem that could be solved, and it's not a reason to discredit Transmilenio as for instance, in the case of Metro in Santiago. In Metro also we have a very poor comfort and long waiting times sometimes, but it's just because you're a victim of your own success. So Transmilenio in Bogotá and Metro in Santiago are so successful in terms of moving large number of people with a very reliable and service and fast service that a lot of people use it. So now the question is, how do you address this problem? In the case of Santiago, for instance, we were able to create express services for Metro, which was very creative. It's very difficult. It's 1 second. Okay, I hope I'm back. I have again a problem. I hope you can hear me. I have a problem with the computer. I hope you can you tell me if you can hear me, because I see a problem in my computer, but I don't know. Can somebody type? Yes, I can hear. Can you hear me? Can you say it again? So I'll keep on. Yes, great. So I'll keep talking. I thank you very much. So I'll move back to the question where I was. We were talking about the declining speed in Transmilenio. I think there's many things we can improve in the case of Transmilenio. For instance, I think you've done really well by having express services, as we did in Santiago for Metro. Even without having an overpassing line, we were able to do it, and that increased our capacity. Transmilenio had to work in the same direction. If Calle 7, for instance, or Calle 100, it's a problem, we should be able to maybe be willing to implement in infrastructure as we're willing to implement in infrastructure for Metro. I wonder why you can only have underground Metro, but you cannot have an underground pass, for instance, for a BRT. Or you can have a more extended station for a BRT to be able to have a higher frequency. So now the bottleneck, my impression in Transmilenio, is not really the corridor, it's mostly the stops. So the question here now is, how do we increase the size of our stops, the capacity of the stops? And I think it's just a matter of an engineering analysis on how to improve its capacity. Also, I think Transmilenio should keep on increasing the network. Probably Avenida Caracas needs a parallel, like Carrera Séptima, a parallel street that will be able to take some of its capacity and some of its flow and be able to increase the capacity for the whole system. Let me move to the next one. How do you explain that speed in mixed traffic and bus-only lanes is the same? Is it the same city? Yes, it's the same city, but what I'm trying to say is that if you have bus-only lane, but you don't enforce it, so if you just paint a line in the street, nothing really happens unless you enforce it. And when you enforce it, and hopefully you also paint it red, the pavement, then you see around 30% increase in speed. Hi, I'm from India. Did you also do any greenhouse gas emission evaluation and monitoring studies? Sorry, we didn't. And I think that would be very interesting, but we only no, we didn't consider greenhouse emission. Sorry, I don't have any information to share. Do you have data on accidents and how different is the accident exposure in various systems? Well, no, unfortunately I don't. Of course, Metro, the accident is zero. However, what I understand from the information I've seen from Transmilenio, BRT is very efficient in terms of reducing the accidents by segregating the buses. However, worldwide we see BRT corridors that are efficient and some that are not in terms of reducing the accidents. There's a very good report by Embark about safe design for BRT corridors, written by Nicolae Duluta, which I recommend you to read. Have you considered running a regression to determine the impact of distance, fare, and other issues on transit ridership? Yes, that's a very good an interesting problem. We have one of the researchers in our center called David Hensher from Sydney with Colin Muley. They've been working in something like this. It's hard to get very reliable data and to get all the elements that impact it. It's hard to really say that that you have a model that can reflect all the elements, that incorporate all the elements that influence the ridership. We don't have it yet. I know that David has been working in some of this, and he has delivered a paper. But this is a question that is very interesting and that we should work on. But we don't have something conclusive. If you're interested, I would recommend you to look at the work by David Hensher, and also the other group that is doing something like this, our group of MIT, with Nigel Wilson and one of his students called Anson Stewart, is also looking at how developed countries, only at developed countries, systems, performance indicators depend on some of its infrastructure indicators. So Anson Stewart would be the person in that case. Hola Juan Carlos, did you study in some way the relation between the system cost, including subsidy, versus the system performance? No, we didn't. What you see is what you get. What we did is what we showed you, except some other indicators that are part of the I mentioned at the beginning, which are not as interesting. The only thing we have is the fare and the operators we have. Subsidies are tricky. Very often the subsidies are quite hidden, and it's not easy to understand where they are, how big they are. Santiago in that case is pretty transparent, I think, in terms of showing what are the subsidies, but in some other cities are not as easy to get. Do you have information regarding the percentage of trips which are below 10 kilometers? Do you think that if walkability is improved and bicycle facilities integrated, we could get that percentage down from transit to active travel? Yes, we have for these 400 trips, we have a distribution of the distance traveled by each of them, and therefore we have the graph you mentioned. And yes, it is true that a very large percentage of trips are less than 10 kilometers long. Let me see if I can tell you right away what was the percentage in each of the cities. Here, In the case of Santiago, like maybe half of the trips are less than 10 kilometers long. So that's certainly an opportunity for this type of trip. Now I think also that several of these cities don't have the facilities for bikes, and as I think Bogota has done an amazing job. But in the case of Santiago, for instance, we have a very fragmented network, and that's an opportunity that could be improved. Apart from the comparison, this is Darío Hidalgo asking, apart from the comparison with Europe, what do you expect would be next steps for this research? I think that we should try to make this methodology, turn it into a standard, that several cities could try to implement it, even maybe autonomously, saying we're going to follow the BRT centers methodology to compare our cities with the rest. So I would expect to see, this is not very expensive to do, by the way. I think the cost of doing it autonomously, if you have the access for the automatic, it could cost you around, let's say, $15,000, $20,000 to do the analysis of per city. Even less, you could do it. So being able to put your city in comparison to the rest would be really, really interesting, because it allows you to compare and see what works well, what doesn't work well. So that would be my goal. My goal is not only to move to Europe, but also to see if we can enchant other cities to move in the same direction and turn this into a standard of analysis. To be honest, our work was not easy. It was hard for us sometimes to be able to explain to the other cities what was being done. So if we were to do this, it would be very important to have a particular office like our center to be able to guarantee that what is being done is really comparable to what other cities have done in terms of the methodology followed to raise the information. I have here another question. The study considered the extra walking and waiting time for transfers? Yes. So when we talk about waiting, it was the sum of the waiting across all the legs, and the sum of the walking across the access, the egress, and the transfers. Yes. Yeah. Here let me see if we have more questions. Yes, here's another question. Are there places that use underground buses and infrastructure that could be modeled here? Follow up to your comment a little while ago. The closest I see is the Silver Line in Boston, where they have buses running underground, and it works really well. It's really a very good and high standard service, which of course is much cheaper than running a railway, but of course also it's more expensive than running the buses in the surface. But this is something that we should consider. It's not that there's an intermediate point between running cheap, inexpensive infrastructure for congested buses in the surface, or very expensive underground fast trains underground. I think there's something in between, which could be something like having, especially when you go through congested areas, having the buses going underground, and where they can go then up, and it's going to be much more flexible, because your trains will never go through your neighborhood. However, if you have the buses going underground, they can go to the surface and then move into the neighborhood. So closer to what, for instance, Muñoz has been doing, in which the express and the local services and local buses move into the BRT corridor. Thanks for this very interesting talk regarding the data and the study. Can this be made available to research institutions? Yes, we will be happy to do so. Just ask, and maybe we'll be able to share it. No problem, John. Is there any relationship between trip times and trip speeds in relation to land use densities? We haven't analyzed that, and that would be interesting to do. I'm sorry, I don't have questions for answer for that. No, we didn't do the analysis. Sorry, we didn't do also an analysis of the densities of neighborhoods. we did a citywide density, so we don't have the aggregated, the disaggregated effect of densities. Did you find any BRT effect indicator that were much better for BRT areas than for bus areas? Indicators that were much better for BRT areas than for bus areas. No? Let me think. Yeah, I think that the express service speed was really amazing. I think that's an issue. Notice that we didn't consider also, which I also think is a strength of BRT, is the number of, it was the capacity of the BRT. We didn't measure, but we did measure the speed. And I think that that's a very strong BRT effect which is the rapid, right? And that's something that we didn't consider, but we may want to look is how reliable is BRT, kind of the second R, bus instead of BRT, BRRT, bus rapid and reliable transit. How more reliable is BRT in terms of variability of the travel time and the waiting time in comparison to mixed traffic? That's something we haven't done, and it would be interesting to do. That should be a second BRT effect that is probably hidden in the data that we haven't checked. So Xiamen, Sao Paulo are elevated, sure. Darío is saying that Xiamen and Sao Paulo have elevated infrastructure, correct. And Istanbul has a full expressway. Yes, Istanbul runs in the middle of the freeway. Sections in Mexico and Bogota are on expressway. So thank you, Darío, for commenting and adding to my explanation before. That's the end of the questions. I would like to thank everyone. It was a little bit longer than an hour, but it has been, I think, very nice from you to stay the whole day. Oh, I'm sorry, I didn't mention, and I didn't add it. We have our next month presentation is going to be Tony Lindau, and Tony will be talking about Rio de Janeiro, about how about the efforts that Rio de Janeiro has been doing, and this is going to be next month. Going to be informed through the emails you receive. Let me tell you the title is going to be the Embark Brazil and Rio, a partnership to implement a BRT network for the Olympics 2016, and this is going to be on July 2016 as well. July 26th, sorry. Okay, so this is the end of the presentation of the webinar. Thank you very much, and looking forward to share with you another webinar next month. Goodbye.